Hello friends, myself Dr. Nandakumar Ravole is going to deal with fluid mechanics. This is our 25th lecture. So in previous class we have discussed about minor energy losses and numericals over it. So now today we are going to discuss about hydraulic gradient line and total energy line. Let us see what this hydraulic gradient line is. So this hydraulic gradient line is defined as the sum of pressure head, that is P divided by rho g. Sometimes we call this as P divided by W, that is weight density. So rho g is nothing but weight density, and the datum head Z of a flowing fluid in a pipe with respect to certain reference lines. So we take one datum line, and from this datum line we add these two energies, that is pressure head and this datum head, and the total head which we obtain is known as a hydraulic gradient line. So or this is also defined as the line joining endpoints of ordinates showing pressure head and the datum head. So sum of datum head and pressure head. So here the sum is not given. So the reason is that the reference line which is taken here, from that point itself the pressure head is measured, so datum is considered as 0. So the of a flowing fluid from center of pipe, so center of pipe is taken as the datum, therefore he has not added, so P divided by rho g plus of Z. So here Z becomes Z is equal to 0 if we are going to take center of pipe as a datum line. So now let us see how this hydraulic gradient line is. So if we see here, there is a tank in which water is filled up, and if we see in this tank, the water filled is up to the height of h meters from center of pipe. So this is the static head of water in the tank, and this static head of water is going to flow through this pipe connected to this tank. Let us assume that at point A, static head is h meters. So as this liquid enters into this pipe, so initially there will be a loss. That loss is a loss at inlet, Hi. So this Hi we are going to subtract from static head. And this is the kinetic head, V square divided by 2g. So sum of potential head, that is pressure head, P divided by rho g plus of Z. So Z is assumed to be 0. So this is a rho g, P divided by rho g. P divided by rho g from point G to this center line. So this is nothing but the hydraulic gradient at inlet. And as we move through this pipe, as the water flows through this pipe, the frictional losses are going to occur, and because of that, this pressure head is going to decrease till it comes at outlet. So this becomes 0. So this line which is representing a dotted line is known as H.G.L. So hydraulic gradient line. Now we will discuss about the total energy line. So total energy line is nothing but the sum of the pressure head, then kinetic head, and datum head. So if we add all these, that is pressure head, then kinetic head and datum head, then the total energy line we get. So total energy at the inlet is h meters. So because of loss due to entry of fluid or liquid into this pipe is Hi. So we are going to subtract Hi from this total h meters of height or h meters of head, and we are going to take initial point. Then we are going to subtract the head loss due to friction gradually. Head loss due to friction is going to increase with the length. As we know, HF is equal to 4 F.L V square divided by 2GD. 4F and V 2GD for given pipe is going to remain same, whereas as the fluid flows, the length L is going to increase, and because of that this HF is going to increase. So as HF increases, that is subtracted from this total head, and finally we are going to have this total head friction last maximum. So then this point we get, and we are going to draw one line. That line is known as a total energy line. So just we will see how it is defined. It is defined as the line which gives sum of pressure head, then datum head and kinetic head. It is the addition of pressure head, datum head and kinetic head of the flowing fluid with respect to some reference line. So if the center line of pipe is taken as a reference line, Z becomes 0, datum head becomes 0. So or this is defined as the line joining top of vertical ordinates. So vertical ordinates showing the sum of pressure head and kinetic head from the center of pipe. So as he is using the word center of pipe, that is nothing but Z is assumed as 0. So here you can see sum of pressure head, kinetic head and datum head. So this gives point E at the inlet, and gradually this decreases at the rate with increase in the head loss due to friction. Now let us discuss one numerical over this. So from this numerical it will be clear to everyone what is given, or what is this hydraulic gradient line and total energy line. Now this horizontal pipe, the horizontal pipe line having 40-meter long is connected to a water tank. So total length of pipeline is 40 meter, and which is connected to a tank at one end and discharged freely into atmosphere. So this water is discharged freely into atmosphere at the other end for the first 25 meters. So first 25 meters of pipe is having of its length of tank, its length from the tank, the pipe is 150 millimeter diameter, and diameter is suddenly enlarged. So for 25 meters it has got 150 mm diameter, and thereafter its diameter is going to increase to 300 mm, and the height of water level in the tank H is 8 meter above the center of pipe. Considering all losses of head which occur, determine a rate of flow and take coefficient of friction as 0.01 for both sections. So for the pipe of 150 mm diameter and pipe of 300 mm diameter, coefficient of friction is same. And also draw hydraulic gradient line and total energy line. So we have to find out this what is a flow rate Q we have to find out, then H.G.L and total energy line we have to obtain. Now let us see what data is given. So here very first the total length of pipe is given, that is L plus L is equal to L1 plus L2, which is given here, that is 40 meters. Then for first 25 meters, diameter is 150 mm. So that is nothing but 0.15 meter. And for remaining means 15 meter is going to remain. So 25 plus 15 is going to be 40. So for that length, the diameter is 300 mm. That is nothing but 0.3 meter. And the head of water in the tank is 8 meter, and coefficient of friction is 0.01. Then we have to find out Q, discharge, then hydraulic gradient line and total energy line we have to draw. So total head is given by, so when this H is nothing but energy available at the inlet. So energy available at inlet is H, which is 8 meters in this tank. From this figure you can see energy available in tank is 8 meters, and this energy is gradually consumed because of head loss in at inlet, then coefficient head loss because of friction, then head loss at the expansion, and the energy which comes out at this exit, that is point F, is the energy that is pressure energy, kinetic energy daytime energy. So this is the energy coming at the outlet, and the losses which are occurring in this flow is HI, HF1, HE and HF2. So at the inlet, HI head loss at the inlet of pipe, then head loss due to friction, that is HF1 in this first pipe. Then head loss due to sudden expansion, HE, occurs at this enlarged section, and HF2 head loss due to friction occurs in the second section. So these are the losses. So here after this point F, so it is going to be head loss at outlet, or at the outlet of pipe. So this is not considered because we are going to count up to only point F. So what amount of energy is going to remain with this fluid outside this pipe, we are not going to consider. Therefore HO we are not going to count here. So the energy at the end, so P2 divided by rho g, pressure energy becomes 0. And as we are going to take this center line as the reference line, so Z2 is also going to become 0. So now this HI is given by various formulae. HI, HF1, HE and HF2 are given by various formulae. That is HI is 0.5 V1 square divided by 2G. Then HF1 is 4F L1 V1 square divided by 2G V1. Then HE is given by V1 minus V2 square divided by 2G. Then HF2 is given by 4FL2 V2 square divided by 2G V2. And we know Q is equal to A2 V2 is equal to A1 V1. So discharge is given. And head loss at the outlet, if we want to calculate, that is given by HO is equal to V2 square divided by 2G. This we are not going to calculate. And then kinetic energy is obtained by V1 divided by 2G in first pipe and V2 square divided by 2G in second pipe. So this is how we are going to obtain energy at the first pipe and at the second pipe using kinetic energy formula, that is kinetic energy is equal to V1 square divided by 2G. So now how to solve this problem is to be seen. So here what we have to do, so H is given to us, this P2 divided by rho g is 0, that is known, then Z2 is 0, that is known. So V2 is not known to us. So in this H1, HI, we have term V1. So this V1 is converted in terms of V2. HF1, again in this case, we have V1, this V1 is converted in terms of V2. And HE, in this case also V1 we have, this V1 is converted in terms of V2. And HF2 has got V2 itself, it is not necessary to convert. So this equation number 1 gets converted in terms of V2 and we can get the value of V2. Once we get value of V2, we can find out discharge Q. So once we get this value of discharge Q, then we can find out the total gradient, total energy line. So first of all, the energy at inlet, energy in the tank is 8 meters of head. So there will be loss of head at the inlet, that is HI we are going to subtract, we are going to get point B. So after that we are going to reduce for this length of pipe. So at this point we are going to have a energy. So from this point B we are going to reduce this distance HF1 from this point B. So we get point C. From point C again there is a loss due to sudden expansion HE, we are going to draw vertical line. And again there is a loss due to friction. So this loss we are going to reduce from point D gradually up to point E. So this we will get point D to E line. So this is total energy line. So from this total energy line we are going to subtract kinetic energy. So this kinetic energy in first pipe we are going to subtract, we will get first point G. And from point this C we are going to subtract kinetic energy, we will get point H. Then after that we have to subtract kinetic energy from this point D, that is V2 square divided by 2G, we get point I1. And then finally we get subtract kinetic energy from point E, so we get point EF. So here there is increase in this kinetic energy because the velocity here is v1 is larger than v2, therefore the loss in the kinetic energy here is more, and here loss in kinetic energy is less. Therefore the difference gap between these two, total energy line and hydraulic gradient line, is here larger and here it is smaller. That we will see. So now let us start to solve this numerical. So very first, so what is our first formula is H is equal to P2 divided by rho g plus of V2 square divided by 2g plus of Z2 plus of the losses, which are losses, that is He at Hi at inlet Hf1 plus of sudden expansion plus of Hf2. So here Ho is not taken into account. So what we can do is H value we know is equal to P2 divided by rho g is 0 plus of V2 square divided by 2g. Z2 is taken as 0, then plus of these losses we can write as Hi plus of Hf1 plus of He plus of Hf2 we can call. So now already as we know what is Hi, what is Hf1. So Hi, head loss at inlet. So head loss at inlet of pipe is given by 0.5 V1 square divided by 2g. Then head loss at in first pipe head loss due to friction, that is given by 4 EF EL1 V1 square divided by 2g D1. Then head sudden expansion, head loss due to sudden expansion He is given by, that is V1 square, V1 minus V2 square divided by 2g. Then Hf2, head loss due to friction in second pipe, is given by Hf2, which is equal to 4FL2 V2 square divided by 2g D2. So now what we can do here is, everywhere wherever there is V1, so this V1 is to be converted in terms of V2, this V1 is to be converted in terms of V2, so this V1 is converted in terms of V2, and if we substitute all these values of Hi, Hf1, He, Hf2 in this second equation, so this is first equation and this is second equation, so this equation gets converted in terms of V2, so there we can find out value of velocity, that is V2. So as we know A1 V1 is equal to A2 V2, so therefore V1 is equal to velocity V1 is equal to A2 divided by A1 into V2. So A1 can be written as pi by 4 D1 square divided by pi by 4 D2 square into V2. So pi by 4 gets cancelled. So we can write this as D1 divided by D2 square into V2. So we know D1 value and D2 value. D1 is equal to 0.3, which is the diameter of first pipe, and diameter of second pipe is 0.15 whole square into V2. So on simplification, this becomes 4 into V2. So now we got this relation as V1 is equal to 4 times V2. So this first equation becomes, Hi equation becomes 0.5 in place of V1 if we substitute 5 V2 square, so that is 25 V2 square divided by 2g. then this equation HF1 becomes 4FEL1 into 16 V2 square. Sorry, this is 4 means 4 for the 16, so this is not 25, 16 V2 square, 16 V2 square divided by 2G d1. So this equation HE becomes V1 is 4 V2, 4 V2 minus V2 is 3 V2 square means 9 V2 square divided by 2G. So this is 4 V1, 4 V2 minus V1 V2. This is 3 V2 square, 3 V2 square means 9 into V2 square. So this is 9 into V2 square. So we are going to have these new equations. So this is going to be 8 into 0.4 is 4 V2 square. So this is going to be 4 V2 square divided by G, or 8 V2 square divided by 2G. So we can call this as, so this is going to be, so what's we can substitute it directly. So this is 8 V2 square, then this is going to be, if we simplify this completely, so if you substitute F value, then L1 value, that we will see. Okay, so in next slide we will have these equations and we will simplify. So now HI, what we opted HI is equal to, just now we see here, HI is equal to 8 V2 square divided by 2G. 8 V2 square divided by 2G. Okay, then HF1 is equal to 4 FEL1, then V1 square, in place of V1 square it was 16 V2 square, 16 V2 square divided by 2G d1. Now if we substitute 4 into coefficient of friction, which is given in this problem, is 0.01, you can see here coefficient of friction is 0.01 into L1 is given, that is 25 meters into 16 into V2 square divided by 2G into d1. d1 diameter is 0.15 meter. So this G value we are not going to substitute because we want this in terms of V square divided by 2G. So therefore on simplification this is going to become 106.67 V2 square divided by 2G. So as here there is a V2 square divided by 2G, some constant number into V2 square divided by 2G. Now we'll see this HE. HE is equal to, just now we have obtained here as 9 V2 square divided by 2G. 9 V2 square divided by 2G, which is in required form. Then HF2, if we see HF2, HF2 is equal to 4 FEL2 V2 square divided by 2G d2. So now 4 into F value is 0.01 into L2 value is 15 meters, which is given in the problem. L2 value is 15 meters. Then V2 square divided by 2G as it is into d2 value, diameter 2 is 0.3. So if we simplify this we are going to get as 2 into V2 square divided by 2G. So now we have losses HI, HF1, HE and HF2. So substituting all these equations in the values of these head losses in equation number 2. So this is the equation number 2. So we get, so in this equation number 2 we will substitute HI, HF1, HE, HF2 and V2 square divided by 2G and 8. So in this we substitute all these losses and we get a new value here, that is 8 is equal to, so it was V2 square divided by 2G plus of HI plus of HF1 plus of HE plus of HF2. So here this becomes 8 is equal to V2 square divided by 2G plus of HI value is 8 V2 square divided by 2G plus of HF1 is 106.67 V2 square divided by 2G plus of 9 V2 square divided by 2G plus of 2 V2 square divided by 2G. So V2 square divided by 2G is taken common. 8 is equal to, so if we take V2 square divided by 2G common, so here it will be 1. Here 8 is going to remain plus of 106.67 plus of 9 plus of 2 into V2 square divided by 2G. So if we add all this and substitute value of G is equal to 9.81, so we are going to get here as, so 8 is equal to 126.67 into V2 square divided by 2G. If we simplify this, it is going to become 126.67 into V2 square divided by 2G. 8 is equal to, so this is going to be from this. Then we will see this 8 is equal to 126.67 V2 square divided by 2G. So if we transfer these constants on other side, V2 square is equal to 8 into 2 into G divided by 126 or 126.67, or this is equal to 8 into 2 into 9.81 divided by 126.67. So V2 is equal to square root of 8 into 2 into 9.81 divided by 126.7. So we get V2 velocity as 1.113 meters per second. So now we know velocity V2. So therefore we can find out Q. Discharge Q is equal to A2 into V2. So A2 is equal to pi by 4 into D2 square into V2. So pi by 4 into D2, diameter of second pipe is 0.3 square into velocity is 1.113. So discharge we are going to get as 0.07867 meter cube per second. So this is the discharge, and if we want to convert it into liters, so it will be, multiplying it by 1000, it will be 78.67 liters per second. So this is the discharge. Now the question left with us is how to draw total energy line and this what you say, hydraulic gradient line. So to find out total energy line and hydraulic gradient line, we'll see this with the help of a diagram. So now, as we will draw one line here with scale, then we mark here a tank. So this is to be taken with scale. So 1 meter is equal to 2 centimeter, 1 meter is equal to 1 centimeter, whatsoever it is. So we are going to draw this tank with the scale, pipe also with scale. So this distance is 25 meters. Means if we are going to take 1 meter is equal to 1 centimeter, then this distance will be 25 centimeter and this will be 15 centimeter. If we are going to take this as 1 meter is equal to 1 centimeter. Now we mark the height of water in this tank. This is 8 meters, which is given in this tank. So as we say that at the inlet, before inlet, so height of head of water above this center of pipe, so this is center of pipe, so this is up to only this is not there. So we will draw first total energy line. So this is 8 meters. So what we have seen is HE, HI. If we obtain by substituting this velocity V2 in this. So now if we want to substitute this HI, substituting V2 value in this HI. So HI is what is given for this HI, that is 0.5 V1 square. So V1 we can obtain, or directly we can substitute V2 also. So HI in terms of V2 is given as here 8 V2 square divided by 2G. 8 V2 square divided by 2G. So V2 value we know, that is 1.113 meters per second. So if we substitute V2 in this, so HI we get as 0.5 meters. Then HF1, which was obtained as HF1 was obtained as 106.67 V2 square divided by 2G. If we substitute V2 value, so HF1 we get as 6.73 meter. Then HE, which was given by equation 9 V2 square divided by 2G. So 9 V2 square divided by 2G, or this was okay, 9 V2 square divided by 2G. 9 V2 square divided by 2G. If we substitute value of V2 and G, we get HE as 0.568 meter, and HF2, which was given by equation 2 V2 square divided by 2G. 2 V2 square divided by 2G. 2v2 square divided by 2g. If we substitute v2 and g value in this, we get hf2 as 0.126 meters. So okay, so now we know hi, hf1, he, and hf2. So first we have marked 8 a at distance of 8 meters from center. So first of all we reduce this distance by 0.5 meters. 0.5 meters means on this graph we have to take it by 0.5 centimeter, means 0.5 5 mm. So we have to mark point B here. Point B is marked, and from this we have to, this is HI, which is reduced from point A. First we are going to mark point A. From point A we are going to mark point B at distance of 0.5 meter. 0.5 meter means, as we are assuming that 1 meter is equal to 1 centimeter scale we are going to take. So here 0.5 meter means we are going to take 0.5 centimeter. There we mark point B. So now this is the horizontal line. From this horizontal line there is a loss. So it was the loss at the inlet is HI. Now here HF1, head loss due to friction in first pipe, is going to occur from this point to this point. So for this 25 meters, so 25 meters means on paper we are going to draw this line of 25 centimeter. So from this point, exactly above this point, we have to take it downward for a distance of 6.73 meter, means 6.73 centimeters. So we get point C here. So this distance will be 6.73 meter actually, but on this scale we have to take it as a 6.73 centimeter. We get point C. So we join this point B to C. Then after this point C, there is decrease in the velocity, and because of decrease in the velocity, there is sudden expansion. Due to sudden expansion, again there is a loss is going to happen, that is 0.568. So 0.568 means we can take 0.6 centimeter from point C. We are going to mark point D at a distance of 0.568 meter, but actually here we are going to mark it in centimeter. We get point D. Then again the head loss due to friction starts, and this head loss due to friction is 0.126 meter, means 0.12 centimeter. 0.12 centimeter means 12 1 0.12 centimeter. So 0.12 centimeter means 1 mm. 1.2 mm we have to take. So from this we have to take 1.2 mm, approximately 1.5 mm below this. So point E we mark here. So distance between, vertical distance between point E and D is 0.126 meter, means 0.126 centimeter. 0.126 centimeter means 0.12 mm. So 1.5 mm approximately we mark point E. So first we obtain point A, then B, then C, then D, and then E. So these points if we join, we get total energy line. So total energy line. So how we got this point A? Once again we see. So first the height of water is 8 meters. We mark point 8. Then we have subtracted HI, head loss due to head loss at inlet of pipe, that is 0.5 meters. So we have taken point B at 0.5 centimeter below A. Then from point B the head loss due to friction starts. So from point B vertically downward we have to take head loss due to friction is 6.73. So as we are going to take a scale of 1 meter is equal to 1 centimeter, so we are going to take this distance vertically downward by 6.73 centimeter. We get point C. Then there is a head loss due to sudden expansion. So sudden expansion head loss is 0.56 meters. So again we are going to take it by 0.56 centimeter or 5.6 mm. So point D we are going to mark. So again the head loss due to friction starts here, HF2 in this pipe for 15 centimeter. So head loss due to friction is 0.126 meter. So again from this point D we are going to move vertically downward for 0.126 centimeter, that is 1.2 mm. We mark point E. Now we have to join these points to get this total energy line. So this total energy line we can mark here, point A to B. Then we have to join point B to C, then vertically downward, then from points D to E. So this red line is known as total energy line. So very first we mark point A, then from point A we mark point B, then from point B we mark point C, then point D, and then point E. So this point E we have marked. Now after this is total energy line. Now we have to find out uh, hydraulic gradient line, H.G.L. So how to mark H.G.L, that we will see. So now what we have to find out is kinetic energy. So kinetic energy in first pipe. So V1 square divided by 2G we have to subtract. So V1 is equal to, as we know, V1 is equal to 4 times V2. So 4 times V2 means 1.113. So we get V1 as 4.452 meters per second. So if we subtract kinetic energy from this point B, as we know, total energy line is sum of pressure energy P divided by rho G plus of kinetic energy divided by V2 square divided by 2G plus Z. So Z we have assumed 0. So now this pressure energy plus kinetic energy is total energy line. So if we subtract this kinetic energy from this total energy line, so hydraulic gradient line is nothing but sum of pressure energy and datum energy. So datum energy is 0. Just if we subtract this kinetic energy from total energy line, we get hydraulic gradient line. So kinetic energy, if we subtract kinetic energy in first pipe is V1 square divided by 2G, and kinetic energy in second pipe is V2 square divided by 2G. So V1 square divided by 2G we can get here as 4.52. So 4.452 square divided by 2 into 9.81. So then we get this as kinetic energy is equal to 1 meter. So from point B we can mark another point G, say point G at a distance of 1 meter, because this is kinetic energy we are going to subtract. So from point C also we can mark point here somewhere at 1 meter, GH say. So we can join G to H. So G to H, this is hydraulic gradient line in first pipe. Then after this we have to subtract from this D this second kinetic energy V2 square divided by 2G. So kinetic energy 2 is equal to V2 square divided by 2G. So V2 is known, that is 1.113 square divided by 2 into 9.81. So this works out Just a minute. So this works out as 0.063 meters. So from point D, we are going to subtract 0.06, means less than 1 mm. So here we are going to get one more point I. So from this we are going to get point I by reducing this distance of 0.063 meter. So 0.063 meter we are going to subtract, and again from point E also we are going to reduce 0.063 meter, means 0.6 mm, approximately 1 mm. So then we are going to get this hydraulic gradient line H.G.L. So this is H.G.L. So from this we are going to reduce 1 meter. From this also we are going to point C, we are going to reduce 1 meter. Then G and H we are going to join, and from point D we are going to reduce 0.63 meter, 0.63 meter, approximately 1 mm. So at 1 mm we get point I, and from E we get point J at 1 mm, and we join this I and J. So these two lines are parallel at a distance of approximately 1 mm, not exactly 1 mm, that is 0.6 mm. And these lines are at a distance of 1 centimeter parallel to each other. So that depends on this kinetic energy. So here velocity is more, so kinetic energy in this case subtracted is more. So here velocity is going to decrease, therefore this is going to move in upward direction. So this is how we are going to find this. Now you can see here from this point A is marked at 8 meter. Then at 0.5 meter we are going to get point B, that is 0.5 meter is HI. HI is marked here. So this HI is 0.5 meter. So again from point B vertically downward we are going to take the distance of 6.73 meters. So we mark point C. So this line which we join is total energy line. This is total energy line. Again due to sudden expansion there is a loss that is subtracted here by 0.56 meter. So 0.56 meter here again we are going to take downward. So again from this point D, exactly here, from this we are going to take in downward direction point E, that is 0.126 meter. So this is HF2. So HF2 is taken here, point E is marked, again we get this line. So this is total energy line. Then by finding kinetic energy in first pipe, so kinetic energy is subtracted here, that is 1 meter. So this distance is taken as 1 meter. So 1 meter in the sense when we take scale it will be 1 centimeter. So 1 meter I just write here point G. So from point C also we take 1 meter. So G and H is joined by a dotted line. So this represents hydraulic gradient line. Then again from point D, so head loss in so kinetic energy loss in second pipe is taken, that is 0.06 meter. So 0.06 meter is subtracted approximately 1 mm. So from here and from point E also 0.06 mm is taken, and then again we draw dotted line joining these 2 points. So this is hydraulic gradient line and this is total energy line. So how the energy is going to decrease with the flow of fluid is shown in this diagram. So this is how we have seen to draw total energy line and hydraulic gradient line. So thank you.